whatever it is named. Now, we can close out of the player settings. We can go back into the build settings. Oftentimes, Unity does not do this by default. But what you have to do is press this button here, which is Add Open Scenes. Now, what this essentially does is if you are building a project, any Unity project, then you might have multiple scenes. What scenes are essentially scenarios. So you may have one setup on one scenario, but using the same resources, you might want to have a completely different scenario. And these are essentially called scenes. And you can have multiples of different projects, and you can even switch between them at runtime. But when you're building a Unity project, you need to have one scene specified which will launch at the start. So add open scenes just means that the currently open scene will be added to the list, and it will be checked. Now, with that, we have all of our main backend settings set up. So if we start building, this will be built on Android, and it will work as an Android application. But right now, we don't have anything in our virtual reality space, and we don't have any interaction in our virtual reality space. So what we can do first is just add a simple cube into our scene. So going into the scene, we right-click. Here we get a list of options, and we can choose 3D object and choose any 3D object here. I will just choose a cube. And this will generate a cube. Now, you can maneuver around in the scene view by using the scroll wheel, by using the right button to aim, or the middle mouse button to pan. And you can also hold down Shift to increase the speed of scrolling in or scrolling out. So you have the right mouse button to aim, and you have the middle mouse button to pan around. This way you can move around in the scene and see what you are dealing with. Now, with this current scene, we have a camera that is placed here. We have a directional light that is just giving the scene some light. If we remove it, then everything will be dark and only illuminated by the ambient background. So the ambient background, which is the blue sky and the brown floor, and the cube that we just added. And at the top of Unity's user interface, there are these 3 buttons. You have play, pause, and step. You generally don't use step, but you do use play, pause. And what you use play for is to test out how your scene functions as if you built it. So it's a good way of debugging your current project. So if we play it now, our scene view will jump to the game view, and we will see what the camera sees. There's no interaction here. It's just we have the cube there and the camera looking at the cube. Now, if we built this for Android, then we would be able to change the view of the camera by tilting the phone, but this is not currently visible in our project. Now, luckily, the Google VR SDK that we imported into our project does have a couple editor-specific functionalities. So we can emulate a virtual reality application by using the editor's play mode. So in order to do that, we have to just go into this folder, Google VR. then in that folder, we have to find prefabs. So prefabs are essentially objects that are complicated structures that you've built in Unity, and then you've saved these full structures. So they're not just models or not just materials or textures, they're models that may have scripts and multiple components attached to them already. And they're very Unity specific. So let's go to prefabs. And the first folder structure here has Gear VR editor emulator. And we can just drag and drop this into our project window. And this will add Gear VR editor emulator into our project. Now, what this means is that if we now press play on our project, then we can use Alt and move the mouse. And this way, we will see what the actual Android application would see if we built the project. Now, do note, there is a small difference happening now. And that is previously, when we started our scene, we saw that the camera could see the cube, and it was quite a distance away from the camera. But this time, if we add the emulator and we run the project, then we no longer see the cube. And if we built this project for Android as well, then we also would not see the cube. And the reason for this is very simple. If I go into the scene view while my project is currently running, and I check the location of the camera, I can see that it is now set at a new location. So this new location is at the center, and it's at the center of the cube. And I'll just end this play run. And if I look at it now, then in my scene view, the camera is outside. So the camera is essentially changing its location. Now, why this is doing this is the way Google VR actually works. And that is by setting the position and rotation of the camera based on what the Android application is assuming the camera's location is. So it's not taking the original location and adding to it, it's setting a new position. And in most applications, we don't want this. In most applications, we want to set a specific location, and then we want to have Android estimate the view it's looking at from that specific location. The way we do that is we go to the hierarchy here, we press right click, and we press create empty. And we can name this whatever we want. I'll just name it as camera handler. This is just an empty object. It does not have any specifics tied to it besides its own position. And that position we can set to 0, 0, 0. And we can take the Gear VR emulator, or sorry, not the Gear VR emulator, the main camera that we have, set its position to 0, 0, 0, and make sure that the rotation is also 0, 0, 0. And then we can just drag the camera into this empty object. So we're making it a child of this empty object. And if we now move this camera handler, then our main camera will still stay at position 0, 0, 0, but this is relative to its parent. This is important because if we now run the application, then we will be able to see the cube because the position of the camera is still at 0, 0, 0 for what it sees. But in actuality, the location is based on where the actual parent of the camera is. So I can change the location of the camera through the parent. Now, do note, however, be careful changing parameters in your scene while your project is running, because if you press play and change some parameters here, and then stop the running of the scene, then it resets to what it was previously. So only do changes outside of it, or if you want to test changes that you want to restore right afterwards, then you can run them in the scene. Now with this, we have a very basic form of viewing something in virtual reality. So you could replace this cube with some sort of a surface and project a video onto it, or something more complicated. But this is the simplest form of virtual reality there is. This has no interaction tied to it. Next, we will be going over how to have an actual interactive system, so a pointer on your camera, so you can, at some form at least, interact with your environment. So in order to do that, we have to go into this Google VR prefabs folder. And in this prefabs folder, we have to go to Cardboard. And here you will see a Gear VR rectile pointer, or sorry, reticle pointer. And this is essentially a visible cursor that you can see in virtual reality. And this one we can just drag and drop under our camera. If we run the scene now, then you'll see that there's this small dot at the center of my screen. Currently, it does not have any interactions because we haven't tied it with anything. But it is a start with something that we can start interacting with, or at least point the user in the correct location. Next, we have to go back to the prefabs and go to Event System. And take the Gear VR Event System prefab and drag it to the main root part of the project. The Gear VR Event System will essentially take in inputs that we have in this environment and translate them for the virtual reality application. That way we can start interacting with virtual elements, or we can start interacting with Unity elements through the virtual interface. And then we need to go to our main camera. We need to go to the inspector window, and we need to add a new component here. So currently we have an event handler. So this takes in different types of events that might happen, a pointer, but the pointer is only on the screen for the user. It has nothing behind it. In order to make it have some sort of a functionality, we need to essentially draw a virtual line from our camera. So wherever our camera is currently looking at, we have to draw a virtual line from it. And anytime something intersects with the line, we can interact with it if it is an interactable object. The way we add this virtual line is we go to the camera inspector and press Add Component. And we look for a component called Gear VR Pointer Physics Raycaster. So Gear VR Pointer. And there's three types, sorry. There's Graphic Raycaster, Input Module, and Physics Raycaster. Now, Input Module we don't need to care about, but there's Graphic and Physics. We care about the Physics one, because the graphics one will not interact with any 3D objects that we have in the scene. It will only interact with user interface elements. So we need to check the physics raycaster. And essentially, this is it in terms of having a system on the camera to make it interactable. But we don't have anything in the scene that is actually interactable. So we can get to that next. A very easy way to test out if our system is in fact working is to, let's say, make this cube interactable in a way that it changes color if our Gear VR system, or sorry, not Gear VR, the virtual reality system starts looking at this cube. So for that, we need to create a small script that can change the color of the cube. So let us go to the main assets folder. So just if you are in this Google VR and prefabs folder, just press assets and you'll get back to the root folder. And in the root folder, do create and create a C# script. And I'll just name this script color changer. Now, if you double click on this, you will open up Visual Studio, and you can edit the script in there, and it's nicely tied in with how Unity works. But I don't think I can change the font size in Visual Studio that easily. So I'm just going to use Notepad++ and edit it there. So I see. Okay. So this folder structure that we have at the bottom here, this is actually the same folder structure that you have on your hard drive. So if I just go into the project window and press assets, then it will show the exact same layout. It's just that it has extra files called these meta files. And these meta files are a way for Unity to understand what it's looking at. So you don't need to care about these, and they rebuild them if you accidentally delete them. And we can now edit the color changer script. Now, is this text size okay for you guys, or should I make it slightly larger?
It's larger, please.
Yep. Where was the... Oh, yes. I can do that. Okay. There we go. Now, when you create a script in Unity, the first thing you will be met with are a couple of imports. These are Unity Engine specific and allow you to use a couple of components inside Unity. It will create a class. So this is how the script will be accessed from your Unity project. And it will create two functions, a start function and an update function. So if you guys have programmed, let's say, in Python or any other programming environment before, and then you probably know that how a main loop works and how to write a simple program. Now, the start function behaves very similar to that. anything you put in this function will be executed at the start of your project. So as soon as you start your project and this script is somewhere active, then it runs all of the code there. But in Unity, you do not have any continuous while loops doing your active processing, because that would tie up too much of your processing speed or processing power. Instead, there are things called update functions. And these are just called either every frame or every physics calculation. So there's an update, and then there's called a fixed update. So these are slightly different update methods. So let's say if you want something to continuously happen, like a continuous color change, then you would put this in the update function, and all the initialization you would put in the start function. For what we will be doing, we do not need the update function nor the start function, so we can delete both of these. Instead, we will just be creating a very simple script that we can call from somewhere else, and this will actively change something on the object that this script is attached to. So I'll create a public function that can be accessed by other parts in Unity. Void, so it doesn't need to return anything, and I'll call it red. And let's say this function, I will attach it to the cube, and it will need to take the render of the cube, get the material from the render, and then change the color in that material field. The way I do that is by writing get component. And what I want to actually get. So if this script is attached to any game object, so like the cube in our scene, then it will look through the game object's attached components. So the cube here has a mesh render. I can actually write here mesh render, and this will be the same thing. So if I attach the script to the cube, like attach it here, then it will look through what it has here. It has a transform, a cube, a mesh render, and a box collider, and the script itself. And it will look for the mesh render and take it. In the mesh render, there is a field called materials. And if we just write material here, this will take the first material in the list if we have only one material. And the material itself has its own set of fields, and one of those is color. And we can just assign this as color.red. Sorry, this one is not capitalized. So this script would, and then if we run it, it would change the cube's color to red if we call this red function. Now I'll duplicate this with a couple other functions. So we have not just the color red, but the color blue. And let's say green. And now we have a way of at least something to call from the cube. Now, in order to call those functions, we need some sort of an event. An event is something that happens in the environment. Let's say if you press, let's say you click on something, you have two colliders intersecting with one another, or something happens in your scene, then this usually calls an event. So we need to have a something that would trigger an event. So on the cube itself, add component and add event trigger. And event trigger essentially makes the cube into an interactable object if your cursor were to hover over it. And since we're using Google VR, then our virtual cursor will act as if it is a real cursor. And now we can add new events to this event trigger. We can add pointer enter, we can add pointer exit, and we can add pointer down. So pointer enter, just press plus and it will add something to the list. And we can click the color changer script and drag it into this none field. So this will call this specific script. And in the no functions tab, we can choose event trigger, or sorry, color changer. So this is the name of our script and what it would do. So let's say green when we enter onto the cube. We can do the same thing for the pointer exit. Another way of adding a function here is by dragging the actual object and then choosing the script here. So this will work the exact same way. And for the last one, I'll drag the script again into this none field, choose color changer, and choose blue. Now, if we run our application, you can see that our white circle that we have, the small circle, if it enters the space of the cube, then the circle goes wider. And the cube also calls its event to change its color. So on enter, it's changing it to green. On exit, it's changing it to red. And if we press it, it will change it to blue. And if we were to build this on Android, then the application would work in a very similar way. But the way we actually interact with things would be by clicking on the actual screen. And the way how this interaction system works is that we can also add something simple like a canvas and a button here. So I'll quickly show that. You don't have to copy this, but let's say we go to add UI canvas. And I'll just make sure that the render mode is in world space, and I'll change the scaling of it. So it's much smaller. And I'll add a button on here. And I'll make the button very large. Just to make sure that you guys can see how it's functioning is that we can have a highlight color here. So a button has a couple of colors for how to interact with it. And if we run this example here, then if we move on to the button, this automatically works. We don't need to add event triggers, and we don't need to add any specifics there. So that's how easy it is to get buttons and UI elements working and simple interaction with 3D objects working in virtual reality. But for now, let's have a lunch break, and afterwards we will start covering how to do movement in virtual reality, for which we will be doing teleportation. And we'll also be covering how to do gaze type inputs. So a hands-free method of inputs. And hopefully from your side, if you guys can maybe download the Android APKs, then while the lunch break happens, then that would also be fantastic. I will upload the current project to the drive, so you can install it from there as well. Okay, so that link should have the project as soon as I upload it there. Okay, so the full project is currently in that folder. And after we have the next practical, I'll upload that project there as well. Same goes for the next 2 days when we start actually working with augmented reality. But thank you for your attention, and I guess we will see in, was it an hour from now? Yes, something like that.
Intenderò scuola, metodo show, Photoshop, rimane per Carolina fattura su come fino a progetti rimane lo stesso, come le compactuazioni un pubblico chiesa nell'interfaccia cita fatto per sottoporre il ruolo di
Non scusavo appunto. Non riesco, non mi spiego. Una stessa la più facile sono state commesse.
Eric, can you hear us?
Yes, I can hear you.
Can we start?
Yes, we can start. Give a minute. Did you get the Android APKs, or sorry, SDKs and stuff installed?
Sorry, I didn't hear it well.
Did you get the Android stuff installed?
Yes.
Oh,
Yes.
okay.
Keni gjithë ato instruksionet që ka dërguar Shalbana, gjitha hapat.
Okay.
Edhe njerëz si po. 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 Po, e keni atë GitHub-in, apo jo, është tjetër? E keni link drive-i. Okej, keni shkarkuar apo? Po, pra, po. Eric,
Yes.
comment, so we download the drive
Project, yes.
to us. Can you resend the drive link, please?
Yeah, I can resend it. So what you have to do is download this project, unzip it, and then here in Unity, press add and select that folder. And if the version is not exactly the same, here on this tab, you can select the closest version. But make sure you don't select the newer version than 2019.4. So 0.3 is fine. 0.4, any number there is fine.
Just a few moments.
Yeah, that's fine.
Eric, can we proceed?
Yes, we can proceed. So, has everyone gotten the project, and have they added it into Unity? If so, we can just click on the project and start it. And then we can continue where we left off. Now, if you do start this project, your view will be very similar to mine. This scaling and colors will be bright. So these can be changed in the settings. But let's move on to the next topic at hand. So thus far, we've made a system where you can build an application that has the ability to somewhat interact with the objects in it, and also interact with UI or user interface elements in your scene as well. I'll just take the camera handler that I have here and bring it closer to the cube so it's not as far away. Okay. And now what we can do next is try and build this application onto the phone. For that, luckily, we have already done all of the prerequisites. I should also have my phone screen duplicated here. And if we do, before you can actually start building your application, you're going to have to enable USB debugging on your phone. Now, for most Android devices, this is very straightforward, but you always have to look up how you can enable it, because almost all Android devices have it in a slightly different way. After you have enabled USB debugging, you can just press build and run. This will prompt you to save the APK. Now, if you cannot, for some reason, get USB debugging to work, or you do not have a USB cable to your phone, then you can just, instead of pressing build and run, you can press build, and you will be prompted with the same window where you can save your APK to a specific location. I'll just call it application, and it will be application.apk. And it will build my project. And it will be saved. I think it is in this folder. And once your APK is saved, then you can either drag it or somehow send it to your phone and open it there, and it will install your application. If you have USB debugging enabled and a USB cable attached to your phone, then it will run the application automatically and install it automatically. So you don't have to toy around with actually sending the APK over. So this just means that no matter if you have a USB connection to your device or not, you can always build an application to Android and then install it there regardless. But it should take a couple of seconds to build it. And once it's built, it will start copying the APK and initialize it. And once it's initialized, it will start my application. So as you can see, I have my phone here, and I'm currently running the same application that I built in Unity, and it has the same interaction methods that I can move on to these objects. They will change color, and if I want to have a click event, then I have to press my screen. So that's the basics of how to get a very simple Gear VR application running on your phone. But next, we will delve into two topics that are very relevant to virtual reality applications on phones. And that is that on phones, you don't always, if you have a, let's say, a Gear VR setup or a Google Cardboard type setup or any type of setup where your phone is attached to your face in form of goggles somehow for these full immersive virtual reality scenarios, then you cannot actually press the screen. Some of these setups do have buttons on the side, but these are not always very comfortable to use. So we will be creating a system of movement in virtual reality that does not require actual presses anywhere. Instead, we will create a system where if you look at an object that you want to teleport to, so like these teleportation pads, then after a couple of seconds, your user will be teleported onto that location. And if you want to move into a different location, then you can look at a different teleportation pad. Now, this part of the workshop will require a lot more programming than the last one. So let's get it started. First off, we will need a single object that we will be interacting with. So for this, I'll just create another cube. And I will make the cube height-wise slightly smaller. But and I will 1 meter lower than my vision. Actually, it might be better to place it. So this will be my ground plane. I can also add a new 3D object that will act as an actual ground plane. So 3D object and plane. And then I can move this down as well. And then all of my objects will be presented in this sort of a scenario. Now, next up, let's create a script for this teleporter. So for this, we'll go to the main folder where we have our previous script. We'll press create, and we'll select C# script, just like last time. And I'll name this stare at object. Has everyone gotten this far? Okay, let's continue. Next, let's open up this script. You guys can open it up in Visual Studio, but I'll be opening it up in Notepad++ so I can show the text in a much larger format. Now again, just like last time, we have a couple of imports. We have the main class, and then we have two functions, a start and an update function. Now this time, we will be requiring, or we will be using both the start and update functions. We'll be initializing a couple of values at the very start, so it's easier for us to work with the object later on. And in the update function, we will be essentially checking if the user is looking at our object or not, or how long they have looked at our object. We'll need a couple of variables at the start. So a good way to indicate to the user that the teleportation is happening or that we are going somewhere or we're interacting with something is to have some sort of a feedback to the user. And for this, I'll be using color. So I will create two public variables for color. And this cube will be interchanging between these two colors. The point will be that if the user is not looking at the teleportation path, then it will be one color. As soon as they move their gaze on top of it, it will change to the second color. And as soon as it gets to the end of the second color or fully saturated in the second color, then our user will be placed on top of the teleporter. Next, we'll need a reference to the mesh render so we can have access to the material itself. And this one I will be making a private variable since we don't need to access it outside of the script. And finally, we'll need another variable, which is the user themselves. So when we start teleporting the user, we need to know what we're actually teleporting, or what is the object reference of what we're teleporting. So this will also be a public variable. And in Unity, all objects that you have in the scene, by default, their parent-most node is called a game object. So you can get all references to its components, like its transformation and the scripts attached to it, through its game object. We'll also add 2 more variables. These will handle the transition period for when we're actually transforming from one color to another. So one of these will be a Boolean variable that will check if we're currently staring at the object or not. And the second one will be a float variable that will be counting down if we are looking at the object, or resetting its variable if we stop looking at it. Now, these are all of our main variables that we'll be working with. We can also add a function here that we can call when the user actually looks at our object. So this function will start calling our color changing. So the timer starts iterating. And we'll call this gaze at. So this will be a function that we can call from our event handler, the same way we call the red or blue or green scripts. And right now, in order to set this up in Unity, this is all we need. It doesn't have any functionality behind it, but we can already start setting things up in Unity. But right now, I'll continue writing the script so we have the actual functionality behind it. First thing we can do is that this Boolean variable that we have here, called gazing, we will be setting it in the event handler for when the pointer is either entering the object or exiting the object. So when it's entering, we'll set it to true, and when it's exiting, we'll set it to false. The reason why we're doing that is then we can have just one function handling both entering and exiting. Otherwise, we would need to have 2 separate functions for this. So if you are entering the object, you can start the color changing. So set this variable to true. And then just return. And otherwise, if our variable here is false, then we'll set the color changing to false. And we can also set the timer back to 0. So these will be needing later on once we start actually updating the timer. Now, in the start method, we will need to initialize a couple of variables. Namely, we have the mesh renderer here called object renderer. And then we have the initial color that we need to set. So the object renderer, this will be get game, or yes, right, get component. And here we can put the mesh render, just like with the color changing script. So just like here, we have the get component mesh render material, but we won't be needing the rest because we will be accessing the material directly from object render. The way we'll be doing this is we'll call object render dot material dot color and set this to, at the start, our inactive color. And later we can change this to the active color over a slow period of time. And finally, we need to go to our update period or update function. So we need to constantly update our timer if we are currently looking at our teleporter. And if we reach a certain value with our timer, then we can teleport to it. So let's first check if we are actually looking at it. And if we are looking at it, we can take the color that we're going to be setting. And instead of just putting the active color here, we want a transition, so slowly transitioning from one color to another. And there are methods for this, and one of the most known method for transitioning between two states, especially used in Unity and Unreal Engine and other types of 3D engines, is called a lerping function, or a slurping function if you want a more complicated version of it. What it essentially does is it takes two states and it takes a floating variable from 0 to 1, and then it calculates the transition between these two and sets the value as that transition state. So we will be using the color version of lerp. We will have our inactive color, then our active color, and finally our timer. In this case, I will be assuming that the timer will be going from 0 to 1, and as soon as it reaches the value 1, we will have the maximum color and we'll also teleport there. But let's actually get to the timer now and start iterating the value of the timer. What we can do here is just continuously add a specific variable to it. And we could have a floating point variable here that is smaller than 1 and just tune it in our scene. But this will be very inaccurate and dependent on the frame rate, or in some cases dependent on the physics calculation rate. So if we want this to be a constant rate in terms of time, then we need to use a variable called delta time. Delta time. And delta time is basically the difference between two frames. So if we leave it as is, then in 1 second, the timer would turn from 0 to 1. If we want to slow this down, we can just divide the value that we have for delta time by any scalar. So I will divide it by 3, and this will make sure that the transition period from 0 to 1 is 3 seconds. Now, after our transition period goes to 1, then we want to teleport our user to this new location and stop all of this transition things. So what we can do here is have a if statement checking that our timer has reached 1. since the addition of these floats might not actually reach the integer 1 specifically, we need to check if it goes over the integer as well. And then we can set the position, or first calculate the position where we'll be teleporting to. So for the new position, we'll be taking the X and Z location of the teleporter. So X is the left or right direction, and Z is the front and back direction, and Y is the height direction. And we only want to set the X and Z. We do not want to set the Y, otherwise our camera will also be teleported to the exact location at the center of our teleporter, and then we won't be able to, our height will change and we won't be able to teleport anywhere else anymore because we'll be intersecting the cube. So in order to take the location of our current object that the script is attached to, we can just call transform. This is the same as doing game object.transform. And by default, game object will be the object that we have the script attached to. We can also have this .transform if you're more comfortable with that. But you can also just leave it as transform, and this is just a by default component of the game object. And transform has its own variables. It has position, rotation, and a couple others. And in position, we'll be taking X. For our height, we'll be taking the height of our actual user. So this will be user.transform .position .y. And the final variable will be the transformation position of the teleporter. So we have transform position X, user transform position Y, and finally transform position Z. And we can now set this as our new user position. And we can save the script. So I'll go to Unity and check if I have made any typos. If you are using Visual Studio, it will tell you if you have any typos right away. But since I'm using Notepad++, then this will not highlight if I am referencing any objects incorrectly. Seems like everything seems to be OK. I can now go and check my cube that I have as a teleporter. I'll rename it as well. This will be my teleporter. And I can add the stare at object script to it. So by just dragging the script here, we'll add my script. Or if I don't want to do it this way, then I can press add component and search up the name of my script and add it that way. Either case, we'll add the script to our object. Now, has everyone gotten this far? So if you have completed the script, you can just take your cube or object that you want to use as the teleporter and just drag it to it. Since I'm already here, I can also show a third way of attaching scripts. So if I remove it here, I can also drag it to the object here in my hierarchy. So sometimes it's preferable to use one, sometimes it's preferable to use another, but there's really no difference. Now, at our current state, we have an inactive color that is black, an active color that is black, and no user. So we just need to drag some components here. For the active color, if we just click on it, we can select the color. So I'll choose a grayish color. For the active, I'll just use some cyan tone. And the user, I will have to take my camera handler, the object that is handling the position of the camera, and place that into my teleporter. Now, right now, if I run the script, my teleporter will turn gray, but it will not interact with the user yet. The reason for that is, in the script, we have this gaze-at function that is used for actual interaction. And we need to set up an event trigger using that function. So just like we did with our initial cube, we need to add an event trigger. So going into the teleporter, we can go to Add Component. Search up the event trigger, and add that. And here we can add two events, pointer enter and pointer exit. So one of these will handle when our pointer is actually moving over the teleporter, and the other one will handle when we're leaving it. Then we can add actual events that will be called when the pointer enters or pointer exits. And we can drag the teleporter stare at object script onto both of these fields. And the function we will be calling is the stare at object gaze at function, the thing that we just wrote. So stare at object gaze at. And when we enter with our mouse, we'll set the Boolean input to true. And if we're exiting, we'll set it to false. And if we run our code now, if we look at our teleporter, it will start changing color. Now, currently, we don't have it set so that the color resets if you look away. But that is an easy change we can make in the script. But if I leave my cursor on the teleporter, then it will change my location onto the location of the teleporter. And since we made the script in such a modular way, we can take this teleporter, select it in our scene hierarchy, press Control-C, Control-V, and we can just duplicate it and make multiple teleporter paths in our scene. So with this, we can now navigate our virtual environment. And if we want to set it so that the color automatically resets, then we can take the same color code that we have here for changing the color. Oh, sorry, the color code we have here at the start for changing the color, and copy paste that to our gaze at function. So this just means that we're calling the inactive color as soon as we stop looking at the object. And with that, we have a teleporter and a way to navigate a scene in virtual reality without the use of actually clicking on the screen, which is very valuable. Now, next, we will be covering how to grab objects in the scene, and afterwards, how to add a similar type of functionality to the grabbing, so a hands-free method of grabbing objects in virtual reality. And we'll be attaching that to our original cube script. Sorry, not cube script, cube object. So for this, let's write a new function, a C script, and I will just call this grab object. Has everyone gotten this far, or do you want a minute to catch up? Okay, is it fine? Okay, okay. While we're waiting, I'll just build the project and demonstrate it on my phone. Okay, so I have my application running here. And if I look at these objects, then I can teleport to them and move around in my scene without actually pressing anything on the screen itself. Okay, has everyone managed to catch up?
Can you send the script for the third one, Eric?
Sorry? The what for the...
Can you send the script for the third one?
Oh, the stare at object. Yes. Upload it into the drive right now. So here's the link. So if you had any problems with this code, or if you got any typos, then you can just copy paste the script, and it should work fine. Tell me when you have the script in your scenario, then I can show how to attach it to your objects one more time.
Eric, you have
Yes.
the second one, not the third. Web object.
Oh, sorry. Did I send the... Yep. Yes, I did send the incorrect one. Okay, the correct one should be up now. So do you have the script? If you have it, then I'll quickly show how to connect it up again. So on the teleporter object, take the stare at object and drag it either here the order here doesn't matter for us, but either drag it here or drag it onto the object here, and then set the colors that you want. So I'll take a gray color here, and a different color here. And then the user, we need to take the camera handler and drag that here. So this is the one that handles the location of our camera, and this will be the object that will be moving around. And then we need to do add component.
Eric, can you give us a little time?
Yes. Yes, so you need to assign this variable here. So at the script, the user needs to be the camera handler. And after you have added the stare at object, make sure you also add the event trigger and the pointer enter and pointer exit events. And then call the function that we have in the stare at script. Otherwise, the stare at script will not do anything. Oh yes, the grab object is currently empty, so I have not done anything to it. So this was the next part we would be moving on to as soon as we get this teleporter thing sorted out. And I'll just show on screen that you then need to take the stare at object script, drag it into these none fields, and for the function, choose the stare at object and the gaze at function. Now, is everything okay? Okay. Albana, is everything all right?
Eric, I guess they need some time to do all steps.
Okay. I would love to be there and help out, but unfortunately, Estonia is still under lockdown. Yes, we can finally. Can we continue? Then okay. Now, if we have all of these teleporter things set up, we can move on to the next part, which is grabbing objects and moving them around the scene. Now, the simplest form of doing that would be to just cast a raycast to our object. Then at that point where we click the object, or click on our screen, then we get a reference of the object's location, and through a bit of trigonometry, we can calculate where the object will be placed if we changed the orientation of the screen, and with that also the orientation of the object that we're moving as well. Right now, we'll only be doing the transformation part for the object. So let me open up the grab object script that I just created. So this is just an empty script. We haven't added anything to it yet. And we will be needing two functions here. One of them is a function. We don't need the start function, for instance, but we will need a function that will handle if our object has been grabbed. So a function we can call outside, and this will be a toggle. And then in our update function, we can check if the object is currently grabbed. And if it is, then it has to follow the orientation of the camera. Now, how we can do that is by first getting a reference of the camera. Then we need a private variable, and this will denote the vector that we're using for the transformation. So this will only hold the distance to the object that we are currently interacting with. It will not hold any other information like the orientation of the object. Private vector tree, grab vector. And then finally, we will need a Boolean variable. This will tell us if we have grabbed the object or if we have not. or if we have the object currently grabbed, or if we do not have it currently grabbed. So this will function essentially the same way as with our stare at the color changing Boolean function. And here we can just have a function that we call out on the onClick event. And we'll call this grabbed. This is the function that we can add later when we click on the object. Sorry, this is the function we can add later when we click on the object. When we click on it, first thing we need to do is set the Boolean value here, but we will be swapping the Boolean value. So this will be acting as if it is a toggle. So what this means is, if our Boolean is currently true and we are tracking the position of the object, and we click on the object, then it will disable following the camera. And if it is disabled and we click on the object, then it will enable following the camera. So this is like every time we click, we either pick up the object or let go of the object. What we need to do next is calculate the vector from the camera to the object based on the camera's current rotation. So if we just calculated a vector from one point to another, then yes, we would get some sort of a reference where the object is, but we don't know where it is in relation to the camera's actual viewing angle. So if we want to transform this vector so that it would actually follow the camera, then we need to get a vector that is based on the camera's viewing angle. So luckily I have this already calculated out. This will be grab vector quaternion.inverse. This quaternion inverse camera rotation. This is the rotation of the camera, and the inverse means the inverse rotation. So we're basically taking the rotation of the camera and getting its rotation as if it was from 0. So how to get the camera rotation back to 0. And if you take any quaternion and multiply it with a vector, then you're rotating that vector based on that rotation. So here we can have the actual vector. It will be this.transform at position minus the camera's position. This is just a basic vector from our camera to our object, and this is a quaternion. Now, for those of you who do not know what quaternions are, Unity has rotations measured in 2 distinct methods. One of them is the method that you might be familiar with, which is the pitch, yaw, and roll. So pitch, yaw, and roll. But for most computational calculations, you cannot just take the pitch, yaw, and roll and either lerp between 2 or multiply the 2 to get a new angle, because the math there will get kind of finicky. And sometimes you won't get proper lerping between two positions. Instead of that, Unity uses quaternions, which are like complex values, but instead of a single complex component, they have 2 extra to the first complex. So it's like 4 numbers in a row. If you plan on working with 3D spaces and 3D environments, then it's a good thing to kind of understand what quaternions are. But for this, you do not need to understand them. Now we have taken the actual vector from the camera to our object, and we have also transformed the vector so it's based on the camera's viewing angle. Now we need to, in the update function, update the location of the object based on this vector. And for that, we'll first check if we're actually grabbing the object or not. This means that we're checking if the object is currently grabbed. And we can update the position of the object. So first off, we'll need the camera position. So this is a reference to from where we're drawing the vector. All right, camera.transform position. And we can add that to our vector. But this vector we will also need to rotate based on if the camera has changed its own rotation. This is the same as we did previously, but we don't need the inverse at this time. We just need the raw rotation. And then we can multiply the rotation with our grab vector. Now I'll show this fully on the screen. I'll quickly check if I have any typos. Seems I do not. So yeah, we have an update function and we have our grab function. Now, once we have written these 2 functions, we can take our script, so this grab object script, we can select the cube we have that interacts when you look at it, and we can attach this script to our cube. And this will prompt for a camera reference. And make sure you take the main camera inside of the camera handler instead of the camera handler like last time. So this time we don't need the position, we don't need to change the position of the camera, but we need to get the actual angle of the camera itself. Now, we're not completely done yet. We just need to add one more simple functionality, and that is actually calling the grab script. And luckily, in the cube that we created at the very start, has already an event trigger attached with the pointer enter, exit, and down. And we just need to go to the pointer down, add another event to the list, and this time bring the new grab object script and call the grabbed function. And that's it. And if we run this scenario now, if we look at our object that we can grab and click on it, it will follow our camera. And if we click on it again, it will release itself. So this is one easy way of interacting with objects so that you can grab them, place them, and do whatever you want with them in virtual reality. But now you notice that this script does have a problem, and that is that I have to constantly click on the object that I want to reference. We can take the script that we just created and we can modify it so it would be slightly more similar to our stare at object. And if we do that, then we can make it so that the object that we're picking up does not need actual clicking involved. It's just going to be a hover-based action. So if we look at the object for a couple of seconds, then it will be picked up. And if we look at it again for a couple of seconds, then it will be placed down, and we can interact with it completely hands-free. Now, at this point, has everyone gotten this far? Because I will be now taking the same script that we just wrote and just editing it a bit so it would have the hover-based functionality. So for now, I just want to make sure that everyone has the scenario working up to this point. Sorry, can you repeat? Okay, perfect. So next part we can do is that we can add two functions that we had in our stare object. So, or sorry, variables that we had in our stare object. And these were the Boolean that checked if we're currently changing and the float timer. So let's just create two replicas of those. So a Boolean that checks if we're currently hovering on the object, and a timer variable. Next, we need to have a function that we can call on the pointer exit, pointer enter and pointer exit. This will be very analogous to what we had with the stare object. So we can first set the isHover value. We're using it the same way that we have an input if we're entering the object. So if the cursor is entering the object, it will be a true value. If we're exiting, it will be a false value. So we're setting it so it starts hovering, or it sets the Boolean of hovering as soon as we enter. And if we exit, then we reset the timer. Notice, however, that in this case, we don't need to have these color changing thing, and a couple other things, because the hover grab will be a bit simpler. Now, next we need to go to the update function and actually use this isHover. And using that, update the timer. So if we are currently hovering, we will add to the timer. And this time I'll just have it as 2 seconds instead of the 3 seconds as previous. And we can also, once we get to the timer being 1, we can set the timer to 0. So this makes sure that if we're currently looking at the object and the timer reaches 1, and we're still looking at the object, then it doesn't constantly call out this function. It only calls it out once. And here we can just call the grab function that we defined earlier. Now, this will behave in a very similar manner as the original script that we had. In it, that we can still use the grab function to either grab or let go of the object, but we now have one extra function that has a Boolean variable that will start a timer or end the timer for grabbing. So we can go to the event trigger of the cube that has this script added to it, and then pointer enter and pointer exit, we can add new functions. And we can take the grab object and drag it to both locations. Now, if you can't actually drag it there for some reason, you can drag it from here. Or you can look up the actual object in the scene. But in this case, make sure that you're checking the scene button, and then you're selecting the correct object, so the cube. So that's why it's good to name all of your objects in the scene with different names. Then you just need to go to the grab object and call out the hover grab. So grab object and hover grab, and for enter it will be a true, and for exit it will be a false. Now with the current setup, we will have a small issue. So if we play the scenario right now, then if we look at the object for 2 seconds, it starts following. So 2 seconds, and it starts following, but it automatically releases the following after 2 seconds of dragging. Now, the reason why this happens is that as soon as the object starts with the dragging, then it resets. And since we're still looking at the cube, then it continues counting up and then retoggles the grab function to let go. So this is not a very good way of interacting with grabbable objects in virtuality. What you can do in order to mitigate this is to have the object that you're grabbing have a sort of a delay in its movement. So it will still follow the cursor, but it will move at a slightly slower pace. And with that, you can shake off the pointer enter and pointer exit interactions, and then enter the object specifically when you want to let go of it. So for that, we can go back to our script. And we have to go to our isGrab function, and we have to do a small edit here. We have to take this transform position, and we will not be applying the new transformation directly to the cube. Instead, we'll be saving this new location. This will be a new position. And just like we did with the colors, there is the function called lerp. So we can do a vector tree.lerp. Have the first position to be the current position of our cube. Oh. Second, be our new position. And the final one will be delta time. So this just means that the object will be following this position that we're giving it, but it will be transitioning to that new location, but at a fixed, constant, and slightly slower pace. Now, if we save this and go back to our scene, we don't need to change any of our event trigger handlers. So we only change the contents of one function. And if we run it now and do the pointer enter, our object will now follow our cursor, and it doesn't let go of the cursor. And if we want to let go of the object, then we need to stare at it for a second, and it will let go. So this is a way of interacting with objects without actually using any sort of touch-based input. This is very similar to how augmented reality applications like the Dockery Smart Helmet or other like goggles-based systems that are meant to be completely hands-free generally operate. So menu interactions happen with these delayed clicks, and interactions with objects in order to move them around also happen with these delayed clicks. But for now, this is all from me for the first day of the workshop. I will quickly upload this project into the Google Drive as well. And tomorrow we will be moving on to AR Foundation and augmented reality. At the start of tomorrow, we will be doing the same type of setup for the AR experience. We will be needing Unity. Let me quickly verify which version of Unity was needed.
Sorry, Eric, can you speak louder?
So, louder. Yes, can you hear me?
Yes, yes.
Okay, okay. So tomorrow, we will be needing Unity 2020.1. or 20.117 in my case. And this will also need Android build support with all of the SDKs and JDKs.
Okay.
Mm-hmm. But for right now, I'll just zip up this project and upload it to the drive. If you have any questions regarding today's workshop, feel free to ask right now.
Centralnie acho que não achaste. Będą są dzisiaj, że tiêm permisa.
Okay, here is the link to the project. So as soon as it's done uploading, it should be there. And I'll also upload the scripts that we wrote today. If there are no questions, then that's it from me. If there are no questions, then that's it from me for today. And I guess we'll see you all tomorrow morning.
Okay, thanks, Eric.
Have a nice day.
Bye.
Bye-bye.